Can science tell us what is true? What is truth? This screenshot is just a random dictionary definition for truth that I grabbed off the internet. You see words used here like real and facts and even events. Accordance with reality is also mentioned. One part of this definition even mentions it's something that is accepted as true. So that's interesting. The takeaway here is that truth is focused on the idea that something is real and that it exists independently of our perceptions. So can scientists tell us what is real? Can we get a picture of it even as flawed humans? We accept that there's a reality that we know imperfectly, and we are all seeing the same general reality but from different sides of it. Experimentation is what shows us what face of reality we are seeing at any given time, and we stitch everyone's views together into a coherent picture of the world. At one point in history, scientists debated whether experiments were for verification, determining if something's true, or falsification, determining if something's false. And we can't talk about falsification without talking about this guy, philosopher Karl Popper. In his book, The Logic of Scientific Discovery, he maps out the claim that you cannot verify, you can only falsify. Experiments tell you if something is false, but not if it is true. Say you want to know what temperature water boils at. You set up a really simple experiment, you get a pot, you put some water in it, and you fire up the heat. You see that when the bubbles start forming and water vapor is coming off the top, the thermometer reads 100 degrees Celsius. Does that mean we have verified that water boils at 100 degrees Celsius? No. This could have been an experimental anomaly, just a fluke. We don't know. So we need to do it again, just to be sure. So we do it again, and we find out it's still 100 degrees. You do it a few more times, and it's still 100 degrees. What if you did it 1,000 times? 1,000,000 times? How many times would be enough before you were absolutely sure it's true? Karl Popper would say that you can't ever choose a cutoff without it being arbitrary. But what you can do is falsify the assumption that water always boils at 100 degrees by doing an experiment to see if there are cases when it doesn't. Maybe you think that the air pressure would change the temperature where the water boils. So you go to the top of a mountain where the pressure is lower and you try your experiment there. You find that it boils at 95 degrees. Aha! You have falsified the claim that water always boils at 100 degrees Celsius. Well, wait a minute though. What does this mean about the boiling point of water? Why do we still say that it's 100 degrees Celsius? That's when we go back to Popper and one of the most common misreadings of him, naive falsification. The idea that falsifying one claim can take down a whole theory. Scientific theories and hypotheses are linked together in systems of claims. You can't disprove a theory with one counterexample because there are always other dimensions to consider. You found that water boils at 100 degrees at sea level and 95 degrees at high altitude. These observations both support the larger idea of the ideal gas law, PV equals nRT. Among many things that this law describes, one phenomenon is that temperature and pressure are related. That means that the relationship between these two things is predictable and follows this law regardless of what pressure, determined here by altitude, that you boil your water at. So while we have falsified that water always boils at 100 degrees Celsius, we have not disproven the ideal gas law. And we pretty much assume in practice that it's 100 degrees because most pressures that we work with will be pretty close to that. Furthermore, it's never really exactly 100 each time. It will vary a little bit between measurements. And we have statistics to help us work out when two readings are functionally the same and when they're actually different from one another. So how do you falsify a whole theory? Well, evidence just needs to pile up against it. It has to become increasingly falsified. So can science tell us what is true? Technically, no. But it is one of the best tools we have so far to help us paint an accurate picture of reality through observation, experimentation, and analysis. Thanks for watching our Understanding the Research Process video series. Favorite this video to come back to it later, or leave us a comment and let us know what else you'd like to know about. See you next time!